Okay, we're back with this little circuit from last night, so it's all working right now. So this was using the LM324 as a comparator, and we're comparing the voltage from this potentiometer here with the voltage from the voltage divider by using these two resistors, one of which is an LDR or a light dependent resistor. And so if I turn my desk lights off, it should turn on. So there we go, the lights come on, and then we turn the lights back on and the light goes off. So when it's dark, the light comes on. If we actually wanted it to be opposite way around, the easiest thing is just to swap these two things over. I think that should do it. And that way, here's my little picture of that one. So that would just be swapping that around. So we went through last night why that would swap the voltage characteristics around. Tonight though, we're going to do something slightly different. And by slightly I mean very similar, but we're going to make it kind of cooler. So we're not going to make something productively useful, but we're going to make a nice little effect. And this is going to lead on to future things. So this is a quick overview again. So thinking back to the op amp, it's drawn as a little triangle. There's two inputs, a plus and a minus, a non-inverting and an inverting input. In this case here, if the non-inverting input, or the plus one, is higher than the lower one, the negative one, then the output will be high, and if it's less than that one, the output will be low. That's how we're using it here. That's much more flexible than that, but that's what we're using it for today. What we're going to think about is a more complicated kind of voltage divider. So with the potentiometer, you can see we're imagining there's essentially two different resistors, and this gives you a point where you can measure the voltage at, and this can shift in this case here. But we don't have to use just two resistors. We can make a more complicated voltage divider. So I'm going to show this little picture here. Turn that off for a second. So in this case here, we've got 5 volts at the top, and then we've got ground at the bottom, and then we've got a bunch of resistors, 1, 2, 3, 4, 5. Now all of these are exactly the same value, so that's kind of important. Though they don't have to be exactly the same value, but in this one here, I've just written an R, but they could be anything. They could be 100 ohms, they could be 1,000 ohms, they could be 10,000 ohms. What matters is that they're identical, so they're dividing up the voltage into little blocks that are the same size. So if you were to read the voltage here, it would be 4 volts. So 5 volts here, 4 volts here, 3 volts here, 2 volts there, 1 volt there. So that's kind of neat. So you've kind of got this little divided up the voltage thing, and a kind of more complicated voltage divider circuit. And so the next step is, how could we use these voltages? Well, if we lead them into our little comparators here, excuse me, we're going to put these into our negative ones here, or the inverting inputs, but we're going to call these the reference inputs for now. So this is our reference point. So this is the voltage that we're comparing everything to. So in this case here, at this one here, we're comparing it to 4 volts. So whatever we're putting into here, which is our test thing. So in this case here, reference is probably a bad word, because reference is actually the thing that's changing here. But we have our test voltage, which is what we're putting into our circuit, and this is going to be fed into all of these circuits here, all of these inputs here. So remember, these are supposed to have very high impedance. They're not supposed to take any current. So they're not this sort of you can imagine them not disrupting the rest of the circuit. So the fact that there's more than one of them feeding off the same input isn't going to affect the actual voltage, in theory. So we've got here's our little voltage. It's going in here. It's going to that one, to that one, that one, and that one. But we're comparing it in each different case to a slightly different thing. So in this case here, we're comparing this input voltage, our test voltage, to 4 volts, because that's coming off here. So if this thing is higher than 4 voltage, the output will be high, and if it's less than 4 volts, the output will be low. So that means this little cross here is like, I think, what used to be the lamp symbol, but I'm just using that for an LED and a resistor in this case here. So this is like a light. So we're making something that glows if this voltage is higher, in this case, than 4 volts. And we're doing the same thing here. If the input voltage is higher than 3 volts, then this one will go on. And if the input voltage is higher than 2 volts, this one will go on. And if the input voltage is higher than 1 volt, then this one will come on. And if the input voltage is less than 1 volt, then nothing will come on. And so that kind of creates an interesting sort of looking effect, that if, say, we had a voltage of 4.5 volts, well, 4.5 volts is higher than 4, 3, 2, and 1. So anything higher than that is going to turn on all the LEDs, all the lights. But if we say it was 2.5, it's not higher than 3, it's certainly not higher than 4, so these two aren't going to come on, but those two are going to come on. So this is helping us make a little simple bar graph circuit, which is a very common thing to use in LM324 for. But I'm going to try and make something interesting out of it at the end. But we're going to do the really basic thing today, which I tried to make a while ago and it didn't work. So now I'm kind of trying to focus on doing it a little bit more clearly. Oh, my hair on the thing. That's not a good look. That just shows you that I still have hair. Right. So this, I'm going to use this little board here. I'm going to build a little voltage divider setup here. And we're going to use a new resistor because I haven't used these ones yet. So I've got a box of... I'm going to get these ones out. So I always thought these are quite interesting because I saw that Julian guy. I keep referring to his channel. He doesn't even know I exist. And he said something about these. He likes the 33K resistors because they're 3 oranges in a row, which is what these ones are. So these are old school ones. So they have the nice, not that thick wires, but they're reasonably thick. So they fit well onto breadboards. So the first step we're going to have to do, we're going to put that one there, and we're going to link these two up. We're going to do this little trick again because I don't think there's enough room in here. We're not going to use the potentiometer part because we might actually. So we're going to use these two bits. So here we've got 2 voltage sources essentially. So we've got our potentiometer one and we've got LDR based one. So we're going to use both of these to test it. So the first thing we want to do is we want to go. So we can be a little bit messy, I think. When I tried to do this before, it was all like squished up into one little ball. One little ball. That's right. I squished it up into my hand like this and threw it in the wastebasket thing. Not that I ever would call it a wastebasket because I don't come from a country that calls it that. But it seems like the appropriate way of calling things if you're going to throw a crumpled up piece of paper into it. You don't say you're going to throw a crumpled up piece of paper into a rubbish bin. But this wasn't a piece of paper anyhow. And it wasn't crumpled up. So this is all very silly. But we say how many resistors do we need? We need 5. Right. And in fact, one of these, that one can go to ground. So that's going to be the bottom part. So I have no idea. There's probably a really neat and tidy way. But I think part of this is that I want it to be obvious what I'm doing. So that one can go to the positive. So it's not entirely neat, but hopefully you can see that this one goes into this line here, so it's leading into this resistor, which is going into there, 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 down to ground. So all we are going to need to do, and I don't think I prepared enough, actually, so this is one I tried before and it's a bit of a mess. So we're going to try without, but we're still going to use these wires because what the hey, let's just go all crazy. And I'm going to use these two. Oh man, what did I do to this? These are going to break anytime soon. I was just reading up about that M-bot thing because I'm thinking of buying one. Those little robot things by Maker People. Some Maker People thing. And they were like, on the video for it, they were like, kids don't understand these DuPont cable things very well, or something like that. And it's like, I really think part of it is that kids would just break them very easily. So I break them very easily, so I don't see why anybody else. So that's actually not going to work because I'm going to put the positive down here. So where is that's a pretty stuffed up one. We'll just use grey. That's going to break. Oh, it broke. Told you that's going to bin. Thankfully these things don't cost too much. So I'm going to quickly link that one across. I feel that's like a bad idea. I feel like this wire here is making everything even more messy than it ever could possibly be. I should have used a shorter one. We'll get there. This is going to be like... well, this is partly, you know, you watch people do stuff. I was just commenting to someone in the weekend that I always think it's very weird that people watch other people playing video games. But then... because why would you do that? Like, why would you not want to play the game? Or why would you not want to make your own game? That's what I always thought. Alright, so... but no people do that. But then I'm like, well, I'm making a video for people to watch me putting pieces of wire into a board. So this one here is going to be the input that was going to change. So we have to, if you look at the little picture that I'm doing this over, the input is going, 4 different wires are going into here. So these 4 wires are going to be the input, the test voltage things. So what then is going to happen is whatever I'm testing, I'm going to plug into there. So that's the theory. So right now we can take the black wire out and we can take the white wire out. So now we've got 2 wires that we could plug into there. So we're going to start by plugging the potentiometer into there. So the voltage that we're going to use as a test is going to be the potentiometer one. I've just realized that we haven't got any space for the LEDs. So we're going to take this whole thing apart. It was a valiant attempt, but it didn't work. But it has, oh, I've gone and broken this really badly now. But it has the plus point that it has LEDs on it already. So where did I put? I put it just on the floor. I just had it. Oh my goodness. Oh, is this it here? What's this? All right. My big collection of 470 ohm resistors. So that one's going to go to there. I feel like I should just cut these down a bit and have some trimmed ones. Alright, we're going to do that because these are a mess. And we should try and make it look a bit nicer. How much time have we got? Alright, I'm not going to put safety glasses on because I'm trusting that I'm not going to shoot myself in the eye, but in general you should. I mean, there's no point. I could just tell you I put safety glasses on, just like you should. But you could have just... you wouldn't really know, would you? Yes, wait. Okay, here we go. I'm going to put my safety glasses on. So I'm putting them on right now, because I'm going to clip the bits of metal off. And I'm going to make these like this size. And then they go on the board a bit nicer. It could be really fancy and get round to making LEDs with built-in resistors. So, how many have I got? 2 more to do. So we'll just do these both together. This is kind of like really stretching it out for basically a very simple thing. If I just did that, I can make them a bit shorter. Okay, that makes me nervous, that one. Now I'm glad I'm wearing safety glasses. Okay. And these go in so nicely for this. Have I mentioned, I'm pretty sure I was supposed to mention, that I really feel like it's not going in very well now. What's up with that? Oh, I spoke too soon. I don't think I cut that one exactly the right length. That they should make resistors in the old school style with the thicker wires for people who want to do like learning electronics, though I expect they would be quite expensive and not really worth it, because they do make it just that little bit more enjoyable, I think, to make these things if the wires are sturdy enough that you can just plug them in like that. Okay, and so we're actually almost done. So we've got to have 4 wires coming from here. Oh, I wish I got the colors the same way. So 4 wires are going to come out of here. I feel like I should have used the longer ones. Too late now. And that spare LM whatchamacallit is going to just sit there. So those are going to go there. So those are going to go to the outputs. Why won't it go on? The sticker bit's in the way. I think I've gone and broken a nail. Oh dear. I better start hurrying up because all this... Oh, come on, just go in. There we go. Oh, now the other side won't go in. Just we can't win. Okay, so those are going to go to the outputs. That one's going to go to sit there for a second. And then the last thing we need is we need the voltage divider one. I don't think this is going to be long. Oh, it is going to be long enough. Yeah, okay, we can't go too crazy, so we'll just take 4 of those out. And one of them is going to go there. And then, alright, I'm going to try and actually think this through instead of mucking around by experimenting afterwards. Because if you get them into the wrong ones, then the lights won't light up in exactly the way you want. You mean, if you know, so we've got to pay attention. Right, it's right here to how these things are laid out. So we've got to make sure that the right input goes to the right output. We've got 12 minutes left. Oh, there are the screwdrivers. They're right here. I was just looking for these. Alright. So, I think we've got all the wires we need. There's just 3 sets of 4 wires. So we will start. So these ones, it doesn't matter which ones they go to. So we'll put those, no, we can leave those to the last minute because they're the ones that are going to be hard to do. So I'm going to go, I'm actually just going to write this in. So, oh, well I don't have to write numbers because they've got numbers on them. So we'll follow this number system here. So this is going to be number 1. So what do I want number 1 to be? The highest voltage or the lowest? Well, it doesn't matter. We'll just go in the same order that's on the page. So the input is going to be the second one in for that one. And this input is the second one from the end. So it's quite nicely laid out, I think. I'm going to have to pull those 2 apart. And put the wires all the way around here. Second from the, no, it's third from the second from the input end. So in all cases, the negative one is the second from the end. So 1, 2, have I got this right? So 1, 2, 3, 4. So that one's going to go there. And we're not going to have that one there. Why was that plugged into the second one? That's the output or the input. It's very confusing. So that one can go there, and then this is the point, this is the important part. So we'll just go back in reverse. We may have to swap these over, otherwise it's going to act the opposite way around to what I want. So 1, so 4, right, that's the output, we want the outputs. The outputs are the outside ones, so that makes it easy. This is a nicely laid out IC, right, compared to those other ones like the 4017, which is just a big mess. So yellow is going to go to that one. So I feel like I've done something a bit goofy because this orange one, how does that work? The orange one's going to have to go underneath the other ones. Alright, so you're going to go to the output of that. I think that's going to work. I'm still wearing my safety goggles, so now I feel really intelligent. Though I put that in the wrong one. That one goes there. I think it's a bit hard to tell. Alright, so that's there, and so now all we have to do is put these ones in, and it doesn't matter which way around they go because they're the same voltage for all of them. So that one can go there and there. Alright, so those 2 go there. This one's just staying over there for a second. In fact, we don't need this wire anymore. Because the little orange LED, in fact, we don't need those things at all. They can just take those ones off. And we've got 2 more, and these are going to go there. I think they're going there. Ow, ow. There's spooky bits on the bottom of that. And it's always a little bit, that's the thing in electronics, there's always, you're going to get stabbed in the finger with something, which probably in the old electronics has lead on it. Okay, so this one's going to be my second test bit, but hopefully, let's just see if it works. It doesn't. Well, that's a bit boring. You know why it doesn't work, of course. I know why it doesn't work. We haven't connected up this wire, so that wire I just threw away. So there's no negative voltage actually here. So now when we connect this up, we've got one LED on, and now when we adjust this, it's what? You're not supposed to look like that. So there's something funny going on with number 2. Maybe it's the wrong way around. Maybe it doesn't actually work at all. Maybe it's broken. Where is my trusty LED tester? That could be the case, right? It could be just broken. Nope, it's not. Well, that's just ruined my day. Why are you not broken? Okay, so what's actually wrong here? Oh, that was that one that I had problems sticking in the thing. So hold on, I'm gonna stuff that one up. How much time have we got? Can I actually get this fixed in the time that I've got left? Probably. I think there's a very good chance. I'm not going to trim the wire on this one. I'm just going to put it straight in. Hey, it was the resistor. All right, that's good. So then we can. What? That's not the way it's supposed to go. So those 2 wires are the wrong way around. So I could fix it on the other bits, but I don't care. It's just got to relatively look okay. Alright, so now what have we got? 2, 3, 4. So as we adjust the potentiometer, we can turn the LEDs up and down. Kind of. Alright, and the neat thing about this little trick is that you can actually, what was I going to say? Chain these things together. So there's another LM324 right here, and in fact we could put another one over here and make a bit more of a complicated circuit. I don't think it'd be that hard actually, because I'm pretty sure we could fit another one in there pretty easily, and then have 8 LEDs or more. Just have to have it more complicated. So in this case here, instead of having 5 resistors, we'd probably have to have, I'm guessing 9 off the top of my head, 9 or 10, 9 I would think. So we'd be dividing it up into 9 bits, and that would give us 8 points to test. But we're going to, we're going to finish it off, but we're going to take out that one. So we're taking out the voltage. I think I took out the wrong one. Alright, no, that was the voltage from the potentiometer, so that's not going to do anything. So it's kind of remembered the voltage that was just on it, which is neat, in a way. No, it's not. Now it's all that one there, so it's not, doesn't do that for very long. So hopefully, right, I took my torch away, but if I cover it, so now it's the opposite way around. It's a dark meter, so the more dark there is, so if we turn off the lights, there'll be maximum darkage, and if we turn the lights back on, that's quite cute. So as I turn various lights on, so we can change the sensitivity by changing this resistor here, and this resistor here. Maybe if we change it to a lower one, so we'll replace this one with the 470, and see what happens. So that should give us a bit more range, I'm hoping. So it goes to there, and I was wrong. I muck that one up. Okay, then maybe we should try it with our awesome new friend, the 33K. So I think there was a 1K before. So what I don't know is I don't know what the LDR, what its kind of range of. This looks promising. So wait a moment. No, this is even worse. Oh no, it's kind of what we would expect. Alright, so if I completely make it dark, it goes all the way to maximum. So the thing I really want to do is I'm just going to swap this around by putting this one now on the positive and that one now on the negative. And so now hopefully it should be the opposite way around. So now when it's dark, all the lights go out, and now we're at normal lightness, and then we turn one light on, we get 3 lights, and we turn all the desk lights on and we get 4 lights. So that actually works quite well, I think. So I'm going to finish it there. We're going to come back and do some more interesting things, and we will talk about hysteresis at some point, though it doesn't really seem to have much of an effect. So it still goes through your finger pretty well. It still sees the light through my finger is what I'm saying. So even if I cover it up with my finger, so I should cover it up with something that's not a finger. What's the best thing to use that's square shaped that's sitting on my desk? Well, we can put a piece of Lego over the top. You'd think that would need a bigger. We'll use Jack Skeleton's base from that, and then so that works a lot better. So then it all goes out. So that's neat. So we are going to move on to using capacitors next, and this is going to be a neat way of seeing capacitors discharge and charge up, and then that's going to lead on to the end of this project, which is going to have the hysteresis stuff in it. Possibly, but we're going to introduce another IC and then try and do it all with LM324s. But you'll see what I mean. Let's not give it all away. So I hope that was interesting. Thanks for watching. Like, share, and subscribe, and see you next time.